Assalamu alaikum. Welcome back to Sterling Learning Channel, where education gets meaning. In this lecture, I'm gonna teach you about the physics 10th numericals. And my name is Electrical Telecom Engineer Zubair Rasheed. I'm a graduate of NUST. Let's begin. Geometrical Optics, Chapter 12. Uh, Before starting numericals, we need to learn these things by heart. We should remember these things by heart. And mirror we have in geometrical optics. In optics we have mirrors and lenses. First we will discuss about mirrors are two types: convex and concave. Convex is a both are curved images, curved mirrors, but convex is reflective from the outside and concave is reflected from the inside. Convex has negative focal length because the focal length the focal point because the light strikes it and gets scattered, does not converge on one place. So the focal point is imaginary lines we draw to the back side, and we get a focal point from where those lines merge and pass from one point. That is the focal point. So the distance from this to this is focal length, which is negative because it is behind the mirror. In case of concave mirrors, refractive side is inside, inner side, and actual light passes through the focal point, so F is positive. These Q and P are the uh, rules are same. First we need to discuss the Q and P. It is the image location formula. This is same for lens and same for uh, mirrors. This formula is same for mirror and same for where here P is the distance of object from mirror, and while Q is the distance of image from mirror, which is formed with by using those mirrors. F is the focal length, distance of focal point, like I have discussed already. This is the distance, this is focal length, this distance is focal length, this is positive and this is negative. And image location formula is 1 over F is equal to 1 over P plus 1 over Q. It is simple. And few more things that we need to know is that Q is positive for real image, Q is negative for imaginary or virtual image. These things are necessary because in some numericals it asks you about the uh, the image formed. Is it real or virtual? In both cases, in concave or convex, these conventions are same. P and Q conventions are same for both mirrors. Let's talk about lenses. In lenses we have convex lens and concave lens. Convex lens is also called converging lens because light comes into this lens and converges to one point, to a focal length. So its F is positive because the light actually passes through that focal point. But in concave lens, light strikes but it goes scattered, and the lines are drawn backward, imaginary lines are drawn backward, and focal point is behind the lens with the or on the opposite direction of the light is going this way, focal point is at the back side, so that is why it is negative. P is real object, positive. These conventions are same as in previous. One thing more here is power of lens. It is 1 over focal length of lens. It is called uh, power of lens, and it has unit as its unit is diopter and denoted by D. Snell's law: sin I over sin R is equal to N. I is the incident angle, R is the refractive angle, N is the refractive index. It is when Snell's law applies when light passes from one medium to another medium. Light ray, medium 1, maybe air, medium 2, maybe water. So light strikes and bends. It is coming this way and then it goes this way. This is the incident angle, this is the refractive angle. So this kind of things happen. Okay, where as n is also expressed as speed of light in air or speed of light in medium. The ratio of these two are gives us the refractive index. So now let's begin to the chapter 12 numericals, the actual work that we have to do. That was just the theory kind of thing we need to know before we could start the numericals. Now, same as the previous, I will not write the statements of numericals. I will just write the numbers 12.1 and then the values or the values given and the values which are required, and then we will solve the question. An object is 10 centimeter in front of convex mirror. The object is in front of convex mirror, so it is P, object distance. So P is 10 centimeter and forms an image 5 centimeter. Image distance is equal to Q equal to 5 centimeter. We need to know the focal length. F is equal to, not need to know, using image location formula. One over F is equal to 1 over P plus 1 over Q. This is the formula. We need to know F. We will put P and Q values. 1 over 10 plus 1 over 5 equal to 1 over F. LCM 10, 1 plus 2. The LCM taking part is simple. If you are studying science, then it is you have studied it a lot, so I do not have any need to explain it to you. You must have a knowledge about it. So 1 over F, and F will go this way, and F is equal to 10 by 3. F is equal to, okay, here Q is minus 5 centimeter because image is behind. So when the image is behind, so negative sign. So it minus Q, minus 5, minus 2, minus 1, and minus 1. F is equal to minus 10. Now for the second, 12.2, we have an object 30 centimeter tall is located in 10. Okay, one thing I had just remembered, I can add it before we could start the numericals, let's see. Let's go behind and here. The image size, the image formed size. The image size which is formed can be calculated by image size is equal to image distance, which is q, and object distance, which is p, into object size. It means if the image is formed, if the object is 10 centimeter away and image is formed 20 centimeter away, that means image would be double in size than the object. Or if image is closer than the object, then image would be smaller. I wrote those things because in 12.2 we are just gonna use this thing. Okay, the object size is given. It is 30 centimeter tall. Object size 30 centimeter and located 10 centimeter from a concave mirror. P is 10.5 centimeter and with a focal length of f is equal to 16 centimeter. Where is the image located? How high it is? Image location, q, distance. Q is what we know, we don't need to know, and image size. We need to know these two things. Now what we have to do, okay, it's done. So using the formula 1 over f is equal to 1 over q plus 1 over p, we can calculate the image location. 1 over f, the value of f is given as 16. 1 over 16 plus, sorry, equal to 1 over q is to be calculated, and 1 over 10.5. Now 1 over q is equal to 1 by 16 minus 1 by 10.5. After calculation, q comes out to be as 30.54. Now for the size of image, we have the formula as given in the start, q over p into size of object. Here the negative is 30.54 over p is what? 10.5 into size of object is 30 centimeters. So calculation we get 87.26 centimeter image size. Now we're gonna do 12.3. This numerical we are given an object and its image in a concave mirror. In a concave mirror are of the same height. Image की image size is equal to object size, yet inverted yet inverted image is inverted when the object is 20 centimeter. P is 20 centimeter from the mirror. What is the focal length of the mirror? F is to be calculated. From this formula, size of image and size of object relationship tells us that the location of image is same as object. So P is equal to Q. Q is equal to P, where P is, if P is 20, then Q is also 20. So by image location formula, we have 1 over F is equal to 1 over P plus 1 over Q, 1 over F, 1 by 20 plus 1 by 20. We have 2 by 20, 2 by 20, 1 over F. F goes there, this comes here, and this goes there. So F is equal to 20 over 2, which comes out to be 10. Centimeters. This is the focal length of the image, the mirror, sorry. Now 12.4. Find the focal length of a mirror that forms an image 5.6 centimeter behind 60 centimeter behind the mirror of an object placed at 34.4 centimeter in front of the mirror. Is the mirror concave or convex? Here Q is behind the image, so 5.66, it would be in the negative value, because if image is behind the mirror, it is negative, because image is behind the and P is 34.4. We need to calculate the focal length. 1 over F is equal to 1 over P plus 1 over Q. 1 over F we need to calculate, 1 over P we put the value here, 1 over 34.4 minus 1 over 5.66. After calculation you get F is equal to minus 6.77. This is the value of focal length. Now we have to tell the image type. is it convex or concave? We need to tell this as well. So for convex we have negative, f is negative for convex, so it is convex mirror. So this is the answer for the question. Now 12.5, but it says in 12.5 an image of statue. Okay, let's take the next page. An image of statue appears to be 11.5 centimeter behind convex mirror with focal length 13.5 centimeter. With find the distance from the statue to the mirror. Q दिया हुआ है कितना appears to be 11.5 centimeter minus में because it is behind, and P is F is also given as 13.5 centimeter. It's asking about P. It's a convex mirror. Convex mirror, and we know that a convex mirror has F as negative. F is negative, so we have minus 13.5. Formula is 1 over F is equal to 1 over P plus 1 over Q. We need to find P, so 1 over P remains on one side, and on the other side 1 over F minus 1 over Q. 1 over P, 1 over minus 13.5, Q is also negative, negative and negative, positive 1 over 11.5. And after solving this, P comes out to be 77.62 centimeters. 77.62 centimeters. An image is produced by concave mirror of focal length 8.7 centimeters. F is equal to 8.7 centimeters, and it is a concave mirror. So we have, for concave mirror we have F as positive, so 8.7 centimeter focal length is okay. The object is 13.2 centimeter tall. Object size 13.2 centimeter tall. P is this 19.3 centimeters. So we need to find the Q and height of image. And second is, if image is twice as far then find the height of the object. So by formula we have 1 over f is equal to 1 over p plus 1 over q. Here we need to find q. So 1 over q on one side, 1 over f minus 1 over p. Putting the values of 1 over f and 1 over q. F and q we have 1 over 8.7 minus 1 over 19.3. We have the q as 15.84. Now for height of image, q over p into object size image size as given in the formulas in the start, 15.84 and over p is 19.3. So height comes out to be 13.2. Height comes out to be 10.83, less than the object size. Now it gives the condition that when p becomes 2p, which means 32 into 19.3 and 38.6, p becomes 38.6, new p becomes 38.6. Then again calculating q, 1 over q is equal to f is same 118.7 minus 1 over 38.6, and q comes out to be here, p becomes 2p and then q becomes this. We calculate the new q because we do the change in the object size, the image location also changes. So new q becomes 11.23. So now again for the calculation of size, I'm gonna finish it here. Size of image new q over new p in this part into the image size, object size 13.2, q over p, this p and p new, q and q new. Okay, p and p new, q and q new. We have the image size as 3.84 centimeter. Nabila uses a concave mirror with for doing her makeup. The makeup mirror has a radius of curvature as r is equal to 38 centimeters. F पूछ रहा है व्हाट इज द फोकल लेंथ ऑफ द मिरर। नबीला की लोकेशन जो है वो 50 सेंटीमीटर दूर है। क्यू की लोकेशन पूछ रहा है वो। उसके बाद विल बी इमेज अपराइट और इन्वर्टेड। इमेज अपराइट और इन्वर्टेड होगा, ये पूछ रहा है। ठीक है, अब हमने करना क्या है, पहले हम f निकालेंगे। हमारे पास रेडियस दिया हुआ है, हमें इसका फॉर्मूला पता है। f इज इक्वल टू, अगर नहीं पता तो अभी याद कर लें, f इज इक्वल टू r/2 होता है। जो रेडियस ऑफ कर्वेचर उसको 2 पे डिवाइड कर दो तो आपके पास फोकल लेंथ आ जाती है। ठीक है, दिस इज द फॉर्मूला फॉर रेडियस टू focal length. F is equal to 19, we have P is equal to 50, and the image type is concave. Concave image, concave mirror, sorry. Concave mirror. So for concave, we have F as positive. So F is 19, P is 50. We can calculate Q. 1 over F is equal to 1 over P plus 1 over Q. 1 over Q is equal to 1 over P minus 1 over F. And putting values, 1 over 50 minus 1 over 19 and 1 over Q. 50 into 19, 50 into 19, 19 minus 50, 1 over Q, and Q becomes 45 or 950 over minus 31, which comes out to be 950 over 31. It comes out to be 30.64. Image would be upright or inverted. It would be inverted because Q is greater than F, so inverted. An object 4 centimeter high is placed at a distance of 12 centimeter. हाइट है हमारे पास 4 सेंटीमीटर ऑब्जेक्ट हाइट। एट सेंटीमीटर दूर है तो P है हमारे पास 8, डिस्टेंस 12 सेंटीमीटर, 12 सेंटीमीटर, P इज इक्वल 12। कन्वेक्स लेंस है, कन्वेक्स लेंस है तो हमारे पास और क्या है जी, और फोकल लेंथ हमारे पास है 8 सेंटीमीटर। पोजीशन एंड साइज ऑफ इमेज हमने Q फाइंड करना है और साइज ऑफ इमेज फाइंड करना है। तो अब क्या करेंगे, सिंपल वही फार्मूला जो वन ओवर एफ इज इक्वल टू 1 ओवर पी प्लस 1 ओवर क्यू। 1 ओवर क्यू निकालना है तो 1 ओवर एफ में से माइनस 1 ओवर पी हो जाएगा। 1 over f क्या है हमारे पास 1 over 8 minus 1 over p है 1 over 12 and q 1 over q is equal to 1 over 8 minus 1 over 12 and q comes out to be 24 centimeters. Now size of image we know the formula very well because we have used it very many times. Q over p into object size or height. Q is 24, p is 12 into 4, 2 into 4, 8 centimeters. Size of image comes out to be 8 centimeters. Magnified because its size of double. Real because q is positive, because pq must be positive for the image to be real, otherwise it is a virtual image. And inverted. Okay. 12.9. We have the conditions as object height 10 centimeters and distance is p is equal to 20 centimeters from a concave lens. और इसकी फोकल लेंथ है आपके पास 15. क्यू फाइंड करना है और नेचर ऑफ इमेज. नेचर ऑफ इमेज भी बतानी है. पहले सिंपल फार्मूला लगेगा 1 over f is equal to 1 over q plus 1 over p. For concave lens we have f as negative, so minus 15. And yes, 1 over q we need to find q, so 1 over q is equal to 1 over p, 1 over f minus 1 over p. F value is minus 15, so minus 1 over minus 15 minus 1 over p is 20, 1 over q. Minus 1 over 15 minus 1 over 20. Solving these two, we get q as minus 8.57 and size of image same formula, q over p minus 8.57 over, ignoring the sign because size cannot be negative, size must be positive, ignoring the sign, over 20 over 20 into object size 10. We get size of image as 4.28 centimeters. Size of image. Now it is a virtual image for nature. Why? Because q is negative. The erect also, and diminished means less, smaller in size. 12.9 is done. 12.10, convex lens f is equal to 6 centimeters. Convex lens to form a virtual image 3 times the size of the object. 3 times the size of the object. Image is equal to 3 times the size of the object. Where must the lens be placed? P is to be calculated. So by image size and object size relationship, we get something like image size it is 3 times the size of the object. Image to Q over P is equal to 3 into object size. If object size, let's take object size is equal to 1. So Q over P to object size 3. Q over P comes out to be 3 into and Q becomes 3P. We need virtual image, so Q must be negative. Q is equal to minus 3P. Now using this formula, 1 over F is equal to 1 over P plus 1 over Q, we need to find one over F, we know 1 over 6, 1 over P minus 1 over Q is minus 3P, so we will put this value here and we get as 1 over 6 is equal to 2 minus 2 over 3P. Solving this, we get 2 over 3P. Then further solving it, we get P is equal to 12 by 3. P is equal to 4 centimeters. The distance comes out to be 4 centimeters. A ray of light from air is incident on a liquid. 12.11 is the second last one is very small. It is second last, and a ray of light from air is incident on a liquid surface at an angle of incidence I is equal to 35 degrees centigrade, and calculate the angle of refraction R we need to calculate, and refractive index is equal to 1.25 and Also calculate the critical angle. We need to know the also the critical angle. Now for this we have something sine I over sine R, refract in incident angle sine and refractive angle sine is equal to n. We have know the formula sine I over n sine 35 over 1.25 is equal to sine R, because we need to find this R. So we get 35 sine 0.5735 over 1.25 is equal to sine R. We get refractive sine angle as 27.31 degrees. Now for critical angle, the refractive angle is 90 degree. So sine 90 over sine I is equal to 1.25. This is for the critical angle calculation. Sine 90 comes on the top, and we have sine 90 over 1.25 is equal to sine I, and sine 90 comes out to be 1. Over 1.25 is equal to sine critical angle. Take sine inverse of both sides. This becomes C and this becomes sine inverse of 1 over 1.25. If we use the calculator, it comes out to be 53.13 degrees. The last one, it's almost 6 in the morning and I'm tired, so after that I'm going to sleep. I'm going to say the Fajr prayer and then I'm going to sleep. The power of convex lens is 5D. Power of lens five diopter. At what distance the object should be placed the lens so that it is real and 2 times larger than image formed. So you 2 times larger image means Q over P would be equal to 2, because Q over P into image object size is equal to image size. If Q over P would be 2, then it would be doubled. So Q over P is 2. So Q is equal to 2P. Q is double. We have power of lens. We need to calculate for this formula we need the value of F. F is equal to, we don't know, F is equal to what? then if the power of is given, we know f is power is equal to 1 over f power. Power is equal to 1 over f, so f is equal to 1 over power, which is 1 over 5, which is 0.2, and in meters and in centimeters is 20 centimeter. F becomes 20 centimeters. And we know F is 20 centimeters and Q is 2 times P. So we need to find what? We need to find P. One over F is equal to 1 over P plus 1 over Q. 1 over F is the value is 20. 1 over P is plus 1 over 2P. Q is equal to 2P. We know that. We have calculated that. 1 over 20 is equal to 1 over 2P. 2 plus 1. 2P. This goes there and this goes there. 2P. 3 into 20. 60. 2P. P is equal to 60 by 2. P is equal to 30 centimeters. We have done the chapter 12, and same thing I would say that I hope it would help you, and if it helps you, then please like it, comment on it, share it with your friends so that they may also get benefit from it. And if there are some confusions that you want to clear them out, then you can ask me again anytime, and you can comment, and I have posted my social media links. If you can contact me there, if you want some help, you can also contact me there. You are allowed to do that. And that's it, what I had to say. And that's all for now, and thank you, and I will see you in the next lecture, and goodbye.